United States Patent Office, Orville Wright and Wilbur Wright of Dayton, Ohio. Flying machine. U.S. Patent Number 821393, patented May 22, 1906. Application filed March 28, 1903, serial number 149220. To all whom it may concern, be it known that we, Orville Wright and Wilbur Wright, citizens of the United States, residing in the city of Dayton, county of Montgomery, and state of Ohio, have invented certain new and useful improvements in flying machines, of which the following is a specification. Our invention relates to that class of flying machines in which the weight is sustained by the reactions resulting when one or more aeroplanes are moved through the air edgewise at a small angle of incidence, either by the application of mechanical power or by the utilization of the force of gravity. The objects of our invention are to provide means for maintaining or restoring the equilibrium or lateral balance of the apparatus, to provide means for guiding the machine both vertically and horizontally, and to provide a structure combining lightness, strength, convenience of construction, and certain other advantages which will hereinafter appear. To these ends, our invention consists in certain novel features which we will now proceed to describe and will then particularly point out in the claims. In the accompanying drawings, Figure 1 is a perspective view of an apparatus embodying our invention in one form. Fig 2 is a plan view of the same, partly in horizontal section and partly broken away. Fig 3 is a side elevation, and Figs 4 and 5 are detail views of one form of flexible joint for connecting the upright standards with the aeroplanes. In flying machines of the character to which this invention relates, the apparatus is supported in the air by reason of the contact between the air and undersurface of one or more aeroplanes, the contact surface being presented at a small angle of incidence to the air. The relative movements of the air and aeroplane may be derived from the motion of the air in the form of wind blowing in the direction opposite to that in which the apparatus is traveling, or by a combined downward and forward movement of the machine, as in starting from an elevated position, or by combination of these two things, and in either case the operation is that of a soaring machine, while power applied to the machine to propel it positively forward will cause the air to support the machine in a similar manner. In either case, owing to the varying conditions to be met, there are numerous disturbing forces which tend to shift the machine from the position which it should occupy to obtain the desired results. It is the CE of object of our invention to provide means for remedying this difficulty, and we will now proceed to describe the construction means of which these results are accomplished. In the accompanying drawings, we have shown an apparatus embodying our invention in one form. In this illustrative embodiment, the machine is shown as comprising two parallel superposed aeroplanes 1 and 2, and this construction we prefer, although our invention may be embodied in a structure having a single aeroplane. Each aeroplane is of considerably greater width from side to side than from front to rear. The four corners of the upper aeroplane are indicated by the reference letters A, B, C, and D, while the corresponding corners of the lower aeroplane 2 are indicated by the reference letters E, F, G, and H. The marginal lines AB and EF indicate the front edges of the aeroplanes. The lateral margins of the upper aeroplane are indicated, respectively, by the lines AD and BC. The lateral margins of the lower aeroplane are indicated, respectively, by the lines EH and FG, while the rear margins of the upper and lower aeroplanes are indicated, respectively, by the lines CD and GH. Before proceeding to a description of the fundamental theory of operation of the structure, we will first describe the preferred mode of constructing the aeroplanes and those portions of the structure which serve to connect the two aeroplanes. Each aeroplane is formed by stretching cloth or other suitable fabric over a frame composed of two parallel transverse spars 3, extending from side to side of the machine, their ends being connected by bows 4, extending from front to rear of the machine. The front and rear spars 3 of each aeroplane are connected by a series of parallel ribs 5, which preferably extend somewhat beyond the rear spar as shown. These spars, bows and ribs are preferably constructed of wood, having the necessary strength combined with lightness and flexibility. Upon this framework, the cloth which forms the supporting surface of the aeroplane is secured, the frame being enclosed in the cloth. The cloth for each aeroplane previously to its attachment to its frame is cut on the bias and made up into a single piece approximately the size and shape of the aeroplane, having the threads of the fabric arranged diagonally to the transverse spars and longitudinal ribs, as indicated at 6 in Fig 2. Thus, the diagonal threads of the cloth form truss systems with the spars and ribs, the threads constituting the diagonal members. A hem is formed at the rear edge of the cloth to receive a wire 7, which is connected to the ends of the rear spar and supported by the rearwardly extending ends of the longitudinal ribs 5, thus forming a rearwardly extending flap or portion of the aeroplane. This construction of the aeroplanes gives a surface which has very great strength to withstand lateral and longitudinal strains, at the same time being capable of being bent or twisted in the manner hereinafter described. When two aeroplanes are employed, as in the construction illustrated, they are connected together by upright standards 8. These standards are substantially rigid, being preferably constructed of wood and of equal length, equally spaced along the front and rear edges of the aeroplane, to which they are connected at their top and bottom ends by hinged joints or universal joints of any suitable description. We've shown one form of connection which may be used for this purpose in Figs 4 and 5 of the drawings. In this construction, each end of the standard 8 has secured to it an I9, which engages with a hook 10, secured to a bracket plate 11, which latter plate is in turn fastened to the spar 3. Diagonal braces or stay wires 12 extend from each end of each standard to the opposite ends of the adjacent, at the front corners of the standards. And as a convenient mode of attaching these parts, I have shown a hook 13 made integral with the hook to receive the end of one of the stay wires, the other stay wire being mounted on the hook 10. The hook 13 is shown as bent down to retain the stay wire in connection to it, while the hook 10 is shown as provided with a pin 14 to hold the stay wire 12 and I9 in position thereon. It will be seen that this construction forms a truss system which gives the whole machine great transverse rigidity and strength, while at the same time the jointed connections of the parts permit the aeroplanes to be bent or twisted in. The manner which we will now proceed to describe. 15 indicates a rope or other flexible connection extending lengthwise of the front of 4, the machine above the lower aeroplane, passing under pulleys or other suitable guides. 16 at the front corners E and F of the lower aeroplane, and extending thence upward and rearward to the upper rear corners C and D of the upper aeroplane, where they are attached, as indicated at 17. To the central portion of this rope there is connected a laterally movable cradle 18, which forms a means for moving the rope lengthwise in one direction or the other, the cradle being movable to either side of the machine. We have devised this cradle as a convenient means for operating the rope 15, and the machine is intended to be generally used with the operator lying face downward so that the operator's body rests on the era. The movements of the operator's body will be understood, however, that the rope, the 15th of May, be manipulated in any suitable manner. 19 indicates a second rope extending transversely of the machine along the rear edge of the body portion of the lower aeroplane, passing under suitable pulleys or guides, 20 at the rear corners G and H of the lower aeroplane, and extending thence diagonally upward to the front corners A and B of the upper aeroplane, where its ends are secured in any suitable manner as indicated at 21. Considering the structure so far as we have now described it, and assuming that the cradle 18 be moved to the